Hello everyone, my name is Kapil Mehta. Today we are starting with the topic topology of metric spaces. It is a topic in BSc Honors Mathematics in 5th semester. Okay, let's begin with the topic. In the introduction of this topic, we have two important definitions. First is an open ball and next is a closed ball. So let's first write down the definitions of open and closed ball. Open ball, let Xt be a metric space and x0 belongs to x. The open ball with center x0 and some radius r greater than 0 denoted by Sx0r is defined as Sx0r is the set of all x belonging to x such that distance between x and x0 is strictly less than 1. Okay, and the closed ball, same definition, slight changes. Let Xd be a matrix space and x0 belongs to x. The closed ball with center x0 and some radius r greater than 0 denoted by S bar x0 r is defined as S bar x0 r is set of all x belonging to x such that distance between x and x0 is strictly less than and equals to 1. So whenever we are talking about a ball, we have to take into account two things: the center of the ball and the radius of the ball. So if we are given a matrix space xt and x0 be any element belonging to x, so open ball with center at x0 and some radius r is the set of all x belonging to x such that distance between x and x0 is strictly less than r. And in the closed ball, we also include the boundary, so the distance between x and x0 is less than and equals to r. Let's understand with the help of an example. Okay. So let's consider x is equals to r square and we are given a Euclidean matrix d of xy is equals to under root x1 minus y1 whole square plus x2 minus y2 whole square. Okay, where x is equals to x1, x2 and y is equals to y1. This is the matrix we are given and let's fix the center. Let's say fix the center at 0, 0 and radius is 1. Okay, so now we are constructing an open and closed ball. Open ball की अगर बात करें, open ball that is Sx not R. X0 is any element belonging to R. Okay. So it is the set of all x belonging to x such that distance between x and x0 is strictly less than r. X0 here is center, which is 0, 0. And x is any arbitrary point, let's say that is x1, x2. So set of all x belonging to x such that distance between x and basically x is x1, x2 and 0, 0 is strictly less than r is 1. So by the definition of the metric set of all x belonging to x, this is under root of x1 minus 0 whole square plus x2 minus 0 whole square is less than 1, strictly less than 1. When we solve the inequality, we will get x1 square plus x2 square is strictly less than 1. Okay, the set of all x belonging to x. X here means set of all x1, x2 belonging to x, which is x is r square. The set of all x1, x2 belonging to r square such that x1 square plus x2 square is strictly less than 1. So what would we get? It would be an open disk because it is less than 1. We will not include the boundary. So this is an R2 plane. X1 square plus x2 square is strictly less than 1. This is the center 0 0 and this is the radius 1. Okay, so all those points inside this disk. However, we will not include the boundary. Boundary is not included. This is an open disk. Okay, so this is an example of an open ball defined on the metric, on this metric. Okay, with center at 0 0 and radius at 1. In the same metric, we can also define the closed ball. Closed ball S bar x naught R is the set of all x belonging to x. X here is x1, x2, such that distance between x and x naught is less than or equals to R. Okay, x here again is x1, x2, and x naught is center, that is 0 0. So set of all x1, x2 belonging to x such that distance of x1, x2 comma center is 0 0 is strictly less than R, that is 1, less than or equal to. So set of all x1, x2 belonging to x such that by the definition of the metric we have this as x1 minus 0 whole square plus x2 minus 0 whole square, which is strictly less than equals to 1. When we solve the inequality, we will get x1 square plus x2 square is less than equal to 1. So we will get a closed ball. Same diagram, but will we also include the boundary of the ball? Okay. Center at this is the radius, but we will also include the boundary. This boundary is also included in the area, the closed ball. This is a closed disk. I hope it is clear. Okay, let's do one more example. Example number 2. So we have x as r, x is r square. Again, here x, we will define the metric dxy is equals to x here is x1, x2, and y is y1, y2. So dxy is maximum of mod x1 minus y1 and mod x2 minus y2. We are defining the metric like this. So again the same steps. अगर open ball की बात करें, open ball which is s x naught r, s x r, s x naught r. X naught is any point. X naught is the center, which is, and we are fixing the center at center, that is x naught is fixing at 0 0 and radius again at 1. So this is center 0 0 and radius is 1. It is the set of all x, that is x1, x2 belonging to x, that is r square, such that d of x x naught is less than radius. Okay. This will give us, by the definition of maximum of x is x1, x2, this is 0 0. Maximum of x1 minus 0 and x2 minus 0 is strictly less than 1. Okay. This will give us mod x and mod x1 and mod x2. Maximum of this is less than 1. If maximum is less than 1, then both the quantities are less than 1. Mod x2 is less than 1. This will give us a square, but we will not include the boundary. This is the center 0 0 and this is the radius 1. Okay, so this is the ball. So in in this open ball, we will all the point in this shaded area will be included, but not the points on the boundary. This is a open square. The same example, if we talk about closed ball, it will be the set of all those points, set of all x belonging to x, such that dx x naught is less than or equals to r. Here also equals to. So in that we will also include the boundary. That will become a closed square or a closed ball. Okay. So you can see from the two examples. In the first example, we had taken the same x but a different matrix, and in the second example, x is same but the metric is different. So you can see that the balls, open or closed ball, is depending on the metric which is defined on it. Obviously, it will depend on the set we are defining on it. Also, it is also depending on the metric we are defining. Next, we have a next definition. That is the definition of an open set. Open set. So let xd be a matrix space